from your side, and you make sure that only your voice is this one audible. If you are sitting in a place where in a room, for example, you close the doors, windows, so that the sound from the outside world should not interfere with your presentation. I I am interested to listen to only your voice, not the disturbance. Is it clear?
Yes, sir.
Okay. Now you can continue.
Good afternoon, everyone. I'm Soumya, 8th EC. I'm here to present our project, Line Follower Smart Bin, under the guidance of Anita Abhigiri ma'am, with my teammates. Next, these are the contents of our project: abstract literature survey, objectives, implementation, advantages, disadvantage, application, conclusion, and feature scope, and reference. Next. Now coming to the abstract, as we know, dustbin is a common and a basic need everywhere. Our project can implement on large scale as well as small scale, but initially we want to go with the small scale. In small working areas, the hospital, canteen, offices, the worker need to go to the dustbin to throw the dustbin waste. But sometimes, because of workload and frustration, the worker is unable to find where the dustbin is. And whenever the worker is taking the waste to dustbin, he or she might spill the waste on the floor. Mainly in hospitals, they use needles and used cotton balls or other materials. If spilled and if someone step on it, it might be harmful and may spread contagious diseases. It's been observed and proved that when the workplace is clean and tidy, the worker work efficiently. So to bring out the best worker and to maintain the cleanliness, we have proposed a project Line Follower Smart Bin. We are implementing a project using Arduino UNO sensors like ultrasonic and IR sensors. The smart bin follows a black line or a white line and no activity, and also indicates the level of waste in dustbin and provides with instant processor to compress waste. Next. Next. Now coming to the objectives. The main objective of our project is to collect the waste from the table. The dustbin moves near to the employee with the help of line follower robot and return back to its original place after collecting waste. While moving to the table, if work obstacle comes, it should detect the obstacle and use the state of the
Soumya,
indicator. Yes, sir.
Soumya, can you hear me?
Yes, sir.
There is a lot of disturbance from your side. I am unable
Sir,
to hear your voice.
sir, not my side. I think
Manisha,
Manisha.
Manisha,
Yes, sir. Mine.
I told you to mute your microphone. Whoever is speaking, let her microphone be on. Others' microphone should be off. Otherwise, I will not be able to hear your voice properly. Now it is okay. So may you continue.
Okay. Okay, sir. The state of the dustbin is indicated by LEDs. Once the red LED blinks, indicating that dustbin is full so that the concerned person can empty the bin. Next. Now coming to the implementation, the proposed system briefs about waste management in office, hospitals, schools, colleges and railways. Switch it Switch is connected to transmitter. When user presses the switch, the encoder IC HT12E. This is 18-pin IC and it connects parallel to serial with 8 address lines and 4 data bits. Encodes the signal and sends to transmitter. The range between the receiver is 0 to 100. Receiver receives the signal and sends to decoder IC HT12D. Here HT12D is 18-pin IC and converts serial to parallel A with 8 address line and 4 data bit, which decodes the received signal and transfer to Arduino UNO. Arduino UNO sends the instruction to motor driver and line followers start moving. Here Arduino UNO is an open source microcontroller based on Atmega 328P microcontroller with 14-pin digital I/O pin, 6 analog I/O pin, and is programmable with Arduino IDE via Type B USB cable. Here, line follower bin follows a black line or a white line surface. Working of line follower bin is depends on the reflected light from white or a black surface. When light falls on the white surface, it gets completely reflected, and in black surface, light gets completely absorbed. It senses the black color and sends to Arduino. Then Arduino drive motor according to program written. Next. This is our front view of the line follower smart bin. Next.
Morning, sir. Myself, Sneha Undri. I am going to explain about RF module. RF signals travel in the transmitter and receiver even when there is an abstraction. RF modules are very small in dimension and have a wide range operating voltage 3 to 12 volt. First, we go with the transmitter section of our RF module. The system transmitting unit is designed to operate at ratio frequency 435 MHz, which is compatible with the architecture of Arduino microcontroller interface used. Trans this is the picture of our transmitter circuit which we have implemented for our project. The power supply is given to the RF transmitter through voltage regulator, which provides a plus 5 volt voltage. Switches are connected to the RF transmitter. Whenever the user presses the switch, the encoder encodes the signal and transmits it to the RF transmitter. The antenna of RF transmitter broadcasts it to the space. The RF transmitter draws no power when transmitting logic 0 while fully suppressing carrier frequency. When the transmitter transmits logic 1, the carrier is fully on about 4.5 milliampere for 3 volt power supply. Manisha, next slide please. Now we go through the circuit diagram of transmitter. Our RF transmitter has 4 pins. First pin is ground, second one is data pin, third one is VCC, and fourth one is antenna. That HT12E IC, it is an encoder IC which encodes the data for RF transmitter. The encoder is capable of encoding the information comprising 12 bits in total, 8-bit address bits and 4-bit data bits. H212E IC is inbuilt. It has a wide range of operating voltage from 2 volt to 12 volt. Now we go with the RF receiver pin section. RF receiver. The reception unit is designed to compatible with the Arduino UNO architecture, which is responsible for receiving and interpreting and actuating the signals received from the receiver. RF receiver works almost like RF transmitter, but in a receiver manner. ST12D IC is used to decode the data received by RF receiver. It is an inbuilt IC. It has an inbuilt oscillator. It is important to note that decoder should also have the same address for them to talk each other. Una, next slide. This is a block diagram of receiver section which will be explained by my teammate.
Good morning, myself Priyanka Janamatti. Now I am explaining block diagram of receiver section. In our receiver section, we can observe we have Arduino board and RF receiver which is connected to HT12E, motor connections which is connected with the L293T motor drive, buzzer, and IR transmitter, IR receiver comparator together form the IR module and LCD display. This is the circuit diagram of our receiver section. At the right hand side, we can observe the DC motor connections. DC motor converts alternative current, electrical current into mechanical energy. So whenever we are running or using a DC motor, we have to make use of L293D IC, which is capable of controlling two DC motors at a time. And it works on the principle of half H bridge. And it is a 16 pin IC, which these connections are: first one is enable pin, which is connected to 5 volt. Second pin is input pin, which is connected to A0 of Arduino board. Third and sixth pin are the output pins, which are connected to DC motor. Fourth and fifth are ground. 7 is input pin, which is connected to Arduino A1. And eighth pin is 12 volt, which is used to supply the voltage to DC motors. Pin number 9 is enable pin, which is 5 volt. And pin number 10 is also input pin, which is connected to Arduino 13. 11 and 14 output pins, which are connected to DC motor. 12 and 13, these pins are connected to ground. 15 pin is input pin, which is connected to Arduino 12. And 16 is connected to plus 5, which is used to run the IC. Then we have connected the buzzer to the pin number A5 of the Arduino, and which is connected with the help of 1 kilo ohms resistor and one transistor. And the left hand side we can observe IR1 and IR2. These are the two outputs which I have taken from the IR module and given to the Arduino board. And S1, S2, S3, S4. These are the data which is taken from the receiver. And here we have LCD display, and the connections of LCD display are as shown. 0 and pin number 15 are connected to ground. Pin number 1 and 14 are connected to plus 5 volt. Pin number 2 is connected to pot, which is used to control the brightness of the LCD. Pin number 3 is enable, which is connected to ground 5. Sorry, I have taken pin numbers from 0 to 15, but in display we have 1 to 16. That's why it is taken something wrong. Then D4, D5, D6, D7, these are connected to Arduino board. These pins are used to display the data. Next. This is the receiver circuit, how it looks like. Next will be continued by my teammate.
Good afternoon, sir. I'm Manisha and I'll be explaining the smart bin lead. So here we have Arduino Uno, because the first Arduino Uno in the receiver section was all run out of the pre-pins. So we had to use a second Arduino Uno. So in this we have 3 ultrasonic sensors, and one is to give the beep sound, that is ultrasonic sensor to the buzzer. Like if for the object detection thing, if any object comes to near to this ultrasonic sensor, then the buzzer beeps. And one more ultrasonic sensor is given in the inside of the dustbin to indicate the status of the waste in the dustbin. So that is, the output will be shown by the LEDs on the dustbin. It will be like, if there is no space in the dustbin, the red LED glows, and if there is space in the dustbin, the green LED glows. So second ultrasonic sensor is over. The third ultrasonic sensor we have used is to open the dustbin lid, like using servo motor to open it automatically and close it. It is for 4 seconds delay we have given, and there is a power supply of 5 volt. And here we have IR sensor module, and this is smart bin lid. So coming to the IR sensor module, here there is IR transmitter. That is a LED that emits light in the range of IR frequency, that is of 700 nanometer to 1 millimeter. Then the IR receiver, we have used two IR modules, and this receiver is a photodiode and it conducts when light falls on it. So it has been coated with black color to absorb the highest amount of light. So it conducts light when it is high. When light falls on it, it is high. So it is a series connection and it is given to the non-inverting terminal of the LM393. And the inverting, it is given to the inverting terminal, and non-inverting terminal is connected to the 1K port. 1K port we have used to preset, here we have used as to preset it. It is used to calibrate the distance range in which objects can be detected. So it is given to 5 volt, the LM393, and we have used 100 ohm, 3.3K, 1K, 10K, and 10K. These R15, R14, and R13, these resistors act as a voltage divider circuit. So, and then the output is given to the IR1, and it works like if the photodiodes, like the output of the photodiode, if it is higher than the threshold set, that is threshold set is by 1K pot. So if it is the photodiodes is higher than the threshold voltage, the op amp output is high, then the LED turns on. Photodiodes, if the photodiodes voltage is less than the threshold voltage, the op amp output is low and the LED turns off. So coming to the smart bin lead, it is connected to the Arduino. So here we have trigger 1, trigger 2, trigger 3, and echo 1, echo 2, echo 3. Here trigger 1 relates to the buzzer, trigger 2 and echo 2 relates to the LED, and trigger 3 and echo 3 relates to the servo motor. We have kept the distance like whenever an object comes near to the ultrasonic sensor that is placed at the bottom of the dustbin, like less than 10 centimeter, then the trigger gets the buzzer gets on. And if any object and if any waste in the dustbin is filled and only 5 centimeter of distance is there between the ultrasonic sensor and the waste, the LED glows, that is red LED glows. Then the servo motor, it is we have kept it as a 10 centimeter. Like if ultrasonic placed on the dustbin lid senses any hand or any object, then the servo motor opens in less than 10 centimeter. It should be. So then next, here we have the smart bin lid open after it senses an object, that is ultrasonic sensor it placed here. And here we have placed LEDs on the smart bin lid. So, and this is the servo motor. So coming to the advantages, disadvantages, and applications. So advantages is that there will be in the area, small area, the reduction in the number of waste bins will be there. Like 3 or 4 dustbins will be replaced by one of the smart bin that we have proposed. And the efficiency of collection of waste and disposal of the waste will be improved, and reduces the manpower as it needs less assistance by the concerned person. It reduces the manpower. Only he needs to check whether the dustbin is full or no, whether there is an object, then he should make it move. And only the disadvantage in our project is frequent replacement of the battery. We need to frequently replace the batteries that we are using. Then the application in offices, we can see we can provide the dustbin in hospitals, railways, canteens, hostels. These are the small scale. In large scale, in industries and industries, we can provide. This will be said by the other teammate.
I would like to conclude by saying that the implementation of line follower smart bin using Arduino and sensor ensures the efficient garbage collection. The system is designed to reduce the amount of human work where it is applicable. It is usually developed for reducing the risk factor for human work and increase the comfort of any worker. The future scopes can be the system of QR code can be added to the proposed project. Robotics arm can be provided for efficient maintenance of surrounding area. Installation of solar panels in such systems maybe reduces the energy consumption. Compressor can be mounted in the dustbin for the effective usage of smart bin space.
These are the references we have gone through, sir. And thank you.
Hello.
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 Now you go for showing the output of your project.
Sure. Priyanka not audible.
Once again, explain. It is on. This is my transmitter. Here we have enable pin, and these are the two switches which
Priyanka.
can be given to.
Priyanka,
Yes, sir.
your project is not visible to me. You have to hold camera in front of your project. I am unable to see your project model.
No, now, sir.
No, no. Still now it is not visible. Whether the camera, have you turned on the camera of your this one laptop?
No, sir. It's on, sir.
It is on only,
Yes, sir.
but the display is not there. No? So you turn it off and turn it on again. Who is going to show the output? Priyanka, no?
Yes, sir.
Now it is visible.
This is my transmitter. Here I have enable pin and two switches. These two switches can be given to two different classrooms. Here I have turned on my project. This is my receiver section. And these are my receiver section circuit diagrams. And here I have my servo motor and two LEDs. Now I'm turning on. Now I'm turning on my enable pin. So my red LED blinking. It indicates that it is receiving signal. Now it is displaying KLCET.
Priyanka, that part is not coming. Okay. So hold your camera near to that hardware. Okay. Go ahead. Go ahead.
Now I am pressing one of the switch. Now it's moving by following the line follower. When it reaches the destination, it will give buzzer sound. After some delay, it will restore its path.
Because of this surface is not good, sir. We have tried it many times, so it is becoming like that.
It's okay. No problem. You continue.
Now I am pressing another switch. Now it's taking different path. It's automatically open and closes after some delay. And here we have the LED. Whenever it gets fully stored, it will display with red LED. If any obstacle comes, it will give buzzer sound.
That's all.
Okay. Priyanka,
Yes, sir.
go to the block diagram of your project. On that, I will ask some questions. Then we'll wind up your this one PPT.
Yes. Present.
Full screen. So this is my first block diagram,
Okay.
which consists of overall system, means transmitter and receiver, line follower, and smart bin lead.
Okay. Here, why
Yes.
you are using L293D?
So this motor driver is used to control the direction of the DC motors.
Uh, Priyanka, you keep quiet. Let others answer. Soumya and Sneha,
Yes, sir.
uh, why
Yes,
do
sir.
you require this L293D? See, you have Arduino, right?
Yes, sir.
Yes.
From the Arduino, can you not directly control the motors? How many motors you are using in your project? 2.
Yes, sir.
Yes, sir.
Yes, sir.
Can't you connect those 2 motors directly to the Arduino, and through the Arduino, can you not control them?
Sir, Arduino works on 5 volts, sir.
Okay.
L293D needs 12 volt. So DC motor, it is a DC motor, sir. So we need a motor driving IC to give the direction high or low according to how we want, sir.
Who is this? Is it Sneha or Soumya?
Sir, it's me, Manisha, sir.
Manisha,
It's Manisha, sir.
I asked the question to the Sneha and Soumya, not to you, Manisha.
Okay, sir. Sorry, sir.
Sneha and Soumya,
Yes, sir.
Yes, sir.
you tell me, cannot we connect the motors directly to the Arduino?
So we cannot connect directly, sir.
Why?
We required a motor driver, sir.
Why?
As
Why?
our
that?
Arduino is as our Arduino is works on 5 volts, sir. But our
Okay.
DC motor requires 12 volt voltage, sir.
Then you are converting that 5 volt to the 12 volt.
No.
Yes, sir.
How?
No, sir. For its we are not converting 12 volts, sir.
See, whether you have used DC motors or stepper motors.
DC, sir.
DC motor, sir.
How many motors you have used? 2.
2, sir.
What is the operating
Yes, sir.
voltage of that 12 volt? What is the operating
Yes,
voltage
sir.
of DC motors?
12, sir.
DC motors is 2 volts, sir, but we have provided DC motors is 9 volts, but we have provided 12 volts, sir.
When it is required 9 volt, why you are giving 12 volt? See,
Our power supply is 12 volts, sir. Well,
now see, the DC motor operating voltage is how much?
9.
Are you sure?
Yes, sir.
DC
Yes, sir.
motors works with 9 volt, 9 volt,
9. Yes, sir.
Yes, sir.
and you are giving 12 volt to it.
Yes, sir.
From which device you are giving 12 volts?
We direct power supply, the battery, sir, 12 volt battery
You are using 12 volt battery.
power supply, sir.
Correct. That you are connecting directly to the DC motors.
Yes, sir.
And Arduino takes how much power supply?
5 volts,
5
sir.
volts, sir.
Then whether you are using another power supply for the Arduino, or are you using the same 12 volt?
We are using same, sir. Here in Arduino, voltage regulator is also there, sir, which regulates 5 volt plus 5 volt.
Arduino itself is having voltage regulator.
Yes, sir.
In the sense you are giving 12 volt to it, automatically it converts it to the 5 volt DC.
Yes, sir.
Okay. If that is the case, in your block diagram, why we have shown a battery output to the voltage regulator? You go to the next slide. Next slide. This one. Hold.
Yes.
Next. This one. Keep it. After battery, you have shown the voltage regulator.
Next.
Yes, sir.
Yes, sir.
Go to the next slide. Voltage regulator.
Yes, sir.
Here you have used a voltage regulator, no?
Yes, sir.
For separate, sir, we have used transmitter for we have used a separate battery, sir.
Battery of how much volt? 9 volt.
Yes, sir.
Then you have given it to the voltage regulator.
Yes, sir.
What is the voltage output you are getting from the regulator?
We are getting the 5 volts, sir.
5 volt DC from the regulator.
Yes, sir.
That you have given to where?
RF transmitter.
HT12E as well as to the RF
Yes, sir.
transmitter.
H212 IC is inbuilt for RF transmitters. We have used it.
Okay. Then show me the power supply to your Arduino in the block diagram, at least here. From where you are connecting that? So this is your Arduino, right?
Yes, sir.
Yes, sir.
Can you show me the power supply to it?
Yes, sir. The 12 volt battery is downside. Downside we have.
See, in your case, both the transmitter as well as receiver, both are present on a dustbin only.
No, sir.
You have a separate model for that transmitter, right?
Yes, sir.
Can you show that to me?
This one, sir.
This is transmitter.
This is transmitter.
Yes, sir.
Okay, fine. And whatever the Arduino you have placed it on the dustbin, that is of the receiver. Okay. You have used two Arduinos.
Yes, sir.
Yes, sir.
One is Mega and other one is Nano.
No, sir. Both are Uno, sir.
Both are Uno only.
Yes, sir.
Yes, sir.
Why you have used two Arduinos?
Because we ran out of the this, sir. We ran out of the pins in first Arduino, that is receiver section, sir. This one.
How many
ran out
pins are
here.
there? Okay. How many pins are there on one Arduino? You know?
14 digital input output pins, sir. 6 PWD pins.
All the 14 digital input and output pins you have already used?
No, sir. I mean, for LED, the first one, sir.
Okay.
The first Arduino, we have connected LCD, motor driver IC, and
Ultrasonic sensor.
the IR sensor, sir. So that constitutes for one Arduino. The second Arduino, we have provided 3 ultrasonic sensors, 2 LEDs, and 1 servo motor, sir. That is on the dustbin. So we had to use the second Arduino board for that, sir.
For what purpose you are using servo motor? To open the dustbin and close it?
Yes, sir.
Okay. Ultrasonic sensors 3 have used, no?
Yes, sir.
One is for detecting the
Object
obstacles.
detection. Yes, sir.
The second one is for
Second one is for
Level of dustbin.
to
measure
find
level
the. Okay. Third one.
Status of the dustbin is one, sir. Third one is servo motor, sir.
Sensor I am asking. Third sensor
Whenever
for what purpose?
whenever the person wants to spill the dustbin. So that time that ultrasonic sensor is used. That sensor.
One you have used outside and one you have used inside.
Yes, sir.
Yes.
Okay, okay. Hello?
Hello.
Yes.
Okay, now you can leave the meeting, not a problem.
Thank you, sir.
Thank you so much, sir. Thank you for your time.